Alright, in this video we're going to be talking about quadratic regression. I know before we talked about linear regression or line of best fit. So this is going to be a curve of best fit because, as you may remember, quadratic is a U-shaped parabola. So these notes will look familiar because they do start off the same way. I'm just going to change a couple things. So for step one, that is still step one. If you're doing this in a calculator, you would have some set of data that would look or represent a quadratic regression. You would still put whatever into L1 and L2. The clearing list and missing list is still accurate to fix that. However, for step two, you're still going to go to stat, still going to calc, but instead of linear regression, in this list, and I know it's kind of hard to see, we're going to do quadratic regression instead. But then the rest of the steps are the same. And then on Desmos, they start off the same way. You go to Desmos, start graphing, do the plus, still do table, put in your x's and y's, but then instead of the y1, the tilde, the squiggly line, mx1 plus b, I know that's really hard to see right here. You're going to put in y1, the tilde, a x1 squared. It should give you the ability to write both of those numbers in, plus bx1 plus c. So basically it's going to look like the equation of a quadratic, just like the line of best fit looked like the equation of a line, but you're going to have different things in there. Okay, so we're going to use, I'm going to go back and forth a couple times to show you what that'll look like. So to compare the difference, linear equations is y equals mx plus b. Quadratic equation is y equals ax squared plus bx plus c. We need to know that in order to help us determine this. So for the first one, now it's asking linear quadratic, and we're skipping the ones I know are linear. So you can already assume this is going to be quadratic, but to show you how we would know that by just graphing it, we're going to plot these points. So negative 3, 2, negative 2, 1, negative 1, negative 1, negative 2, 0, negative 1, and 1, 2. And when you plot the points, they make that U-shaped parabola that we need for our quadratic. That tells us it's going to be a quadratic. Then we can find our equation. So I'll do this one in the calculator, the next one in Desmos, and then switch to a word problem. Sorry, I need to do the equation. Let me write this down real fast. So in our calculator, we would go into stat, go into edit, and then start typing in our L1, L2. So negative 3, negative 2, negative 1, 0, 1, and 2, negative 1, negative 2, negative 1, 2. And then go into stat, scroll over to calculate, go down or hit number 5. We want our X list in L1, our Y list in L2. We don't want a frequent list. Store regression equation. This would be if we are actually using the equation for something. In this case, we're not, so we're just going to calculate it. And it would give us our A, B, and C values. So A is 1, B is 2, C is negative 1. So when we write that equation, it would look similar to the standard form equation we had above, y equals, you can put 1 x squared or just x squared since a is 1, plus 2x minus 1. Minus, right? Yeah. And that would be our curve of best fit that best fits all of these points. Right, now let's do this one. Again, I said that this is going to be quadratic, but you could plot these points as well. So negative 4, 7, negative 2, 6, 0, 5. Oh wait. I think I crossed out the wrong one. I think it was supposed to be, yeah, let's do this. It was supposed to be 3, and I crossed out 4. But, alright, let's try again. So negative 1, negative 5, 2, wow, this is 1, negative 5, 2, negative 2, 3, negative 1, 4, negative 2, and 5, negative 5. If you weren't sure, like how do you know this is going to be quadratic already? One, I looked at my answers. But if you like got a problem with this and you were trying to figure it out, there's one way to see if it's linear or quadratic. Look at your x and y values. So if your x's go in order, lowest, least to greatest, and then they have repeats in the y's, you have a vertex that's going to give you your quadratic. If your x's are all over the place, maybe there's a pattern, maybe there's not, maybe they increase, maybe they don't. And then same thing with your y's, they seem to kind of match that same pattern. That would be a linear function. Right, so we know this is a quadratic. And then I'm going to do this one in Desmos. Let me write this down so I can try it out. So in Desmos, you would hit the plus, make a table, put in all your values. So 1 and negative 5, 2 and negative 2. 3. Once Desmos gives a pattern, if you hit enter, it'll put in the rest of the numbers you want. So 3, 4, 5. We've got negative 1, negative 2, and negative 5. Now you may be able to see it on your graph already, or you may need to hit this plus off to the side, and that will make it kind of zoomed in. And then underneath that, we're going to type y1. I feel like I didn't write that in the notes when I was doing this. Let me go back just to double check. I did, okay. So y1, and then the tilde, if you go into ABC, it is on that page. And then we want a x 1. So type in the 1 first, and then make it squared. Plus b x 1 plus c. So it's going to give you that a, b, and c value, just like it did for a regular line of best fit. So a is negative 1, b is 6, and c is negative 10. So our curve of best fit, or our quadratic regression, would be y equals negative x squared plus 6x minus 10. Now I just want to show you a word problem, and we'll do this both in Desmos and the calculator. So number 10, 1. When you have word problems for per line investment. If you see years, that's going to be a linear thing because years happen linearly, one after another. Or if you're reading a word problem and you think about what is happening, a coin is thrown off the top of the Statue of Liberty. So if you think about how high you'd be at this Statue of Liberty on the top, and it's recording the height after it's thrown after each second. So if you think about that, it's kind of like a curve, an upside down curve. So for this, it would have to be quadratic. We're not going to plug those points to see it, but it would have to be quadratic if you're thinking about it like that. It wouldn't go straight at an angle. Unless you, even if you just dropped it straight down, the wind might move it or anything like that. Okay, so we need to find the equation. So we'll do that in the calculator first. Write these down. I'm going to go back into stat, go back into edit. I'm going to go up to the top and clear the list. Same thing here. And then we have 0, 1, 2, 3, 4. With your word problems or actual application problems, you can't have negative numbers really with your x unless it's dealing with something that's not really real world, because it would have to go up and then down unless you're throwing it underhand, but it's still like it wouldn't be a negative thing. Anyway, so we had 305, 367, 397, 395, and 361. So when you're on the top of the Statue of Liberty and it's going up and then it starts to go back down, what's happening is you threw it up, toss it up, so it's making that upside down view, and then it's falling back down. Okay, so go on to stat, go on to calculate, number 5, the quadratic regression. X list, Y list, those are the same. I do want to store this, but a lot of the times you get like whole numbers, so you don't need to if you write it down. But I'll still do it just to do it. So negative 16, 78, 305. So then our equation would be y equals negative 16x squared plus 78x plus 305. And then you have a couple choices. So we need to find the height of the coin after 7 seconds. So remember, t is each second and h is the height. So if you were doing this by hand, you would put y equals and put 7 in for all your x's. And you could actually calculate that out. You could put in your calculator on the main screen. What I'm going to do is, since if I go on my y equals, that since I stored it, it's already there. If you didn't store it, you would have to retype it in here. And then I'm going to go into my table, and I'm going to look when x is 7. And that would give me 67. So h would equal 67. Let's see, height is in feet. So basically, after 7 seconds, it would almost be to the ground. If you wanted to do it on your main screen, you go second mode. You can let's do this. We'll store this as x, and then put this in, this only works if you store your equation. So if I bring back my equation, alpha trace, I stored it in y1. y1 now has x as 7. It would do the same thing. Right? Now I'm going to do that same thing, but I'm going to do it in Desmos. Now, if you already have something in Desmos, you can use the same table. That way you don't have to retype this equation, and it'll just change the numbers. So I'm just going to do that. If you delete the table, so I'm going to show you what happens. And I add in another one. The table now becomes x2, y2, which means you would have to change your equation to be y2 tilde ax 2 squared plus bx 2 plus c. So keep that in mind. So I'm going to fix all of my numbers. Choose 397. Oh, because I don't have a 5. Especially with your quadratics, because these numbers can get really big really fast. You may not be able to see it, so I'm going to hit the plus. There we go. So it zoomed out to where that is. And I can see my graph, and if I go down, I can see my quadratic regression, which gave me the same numbers as it did before. And then what I want to do, since I'm still trying to find the height of 7, is I'm going to put this in as an equation. So you can put the y equals, you don't need it. So negative 16 x squared plus, 78x plus 305. And now it's going to graph that on top of this. I'm going to change the colors of these so I know which one is which. Let's make this blue. And let's make this. Oh, I can only do blue. Okay. So what happened is the black overlapped it. And now I want to make this a table. And I want to put in my table when x, in this case, is 7. And then I'm able to see if I scroll over when x is 7, y is 67. So that's how you would do that on Desmos. I am going to stop there, and you'll have time to practice others and a few others. Let me know if you have any questions.